Hello and welcome to Shastra. Today we are going to discuss what is data sufficiency. This is a problem type that you will see in many common MBA entrance exams, and you are required here to find basically whether your problem can be solved through the given statements or not. The idea is sufficiency. This is not an MCQ problem. So what are the five options? You can remember them through this acronym 1, 2, TEN. So this is described over here. We are not required to find the solution. We are required to find sufficiency, and we need to maintain a logical flow. So your option A basically implies that statement 1 itself is sufficient while the other is not. Second option is the opposite of that, wherein your second statement is sufficient but 1 is not. Together essentially means 1 plus 2, where you combine both the statements, and only on combining your problem can be solved, means it is sufficient as an information. D would imply 1 or 2. So that is why it is either, where either statement alone is sufficient. Statement E is neither, when none of the given statements can be used to solve the given problem. So basically, what you need to do is maintain a logical flow. We will understand very quickly how. So you begin by analyzing statement 1 alone. So this is your decision box. You can either say yes or a no, which means yes, your problem can be solved, it is sufficient, or no. There are different possibilities from here on. If your statement 1 alone is sufficient, your final answer can either be option A or option D from here. And for a no, it can be either a B or a C or a E. So we will very quickly see how to further drill down. If your answer was yes for option 1, statement 1, then you will decide individually for statement 2. If you have a yes, then your final answer will be D, because both individually are sufficient. If you have a no, if you have a no from here, then your final answer is A. So these are your final answers. So that completes this logical flow. However, if you had a no from option 1, then you can have either B or C or E. So let's see how that will further be broken down. You will now decide for second statement alone. Decide for second statement alone. If you have a yes, then your final answer is option B, and you stop. You don't do anything further. Your answer is B. If you have a no from here, then what you will do is you will combine both the statements, which means you will analyze 1 plus 2 taken together. If it is sufficient, then your final answer is C, and if it is a no, then your final answer is E. So that ways your logical flow of analyzing a data sufficiency problem in this way will help you reach the answer in the most quick manner. Hello and welcome to Shastra. Let's start with this coordinate geometry problem. We are given in xy plane a certain line L1 has how many intersections with this curve? So in order for the intersection points, we should just first graph this given curve itself. The curve is y equals x square plus 2. This is a very standard parabola, and it will be formed like this. This is y equals x square would pass through origin. This is shifted 2 units upwards. So this is going to be having this shape. This point is 0, 2. This is the curve. Now we need to find the line L1 has how many intersections. The first statement is that line L1 does not intersect the x-axis. Now we should now be able to derive that or understand what is a line which does not intersect the x-axis. See, on the coordinate plane, any line that has a non-zero slope like this or like this will always have an x-intercept. Even a vertical line will have an x-intercept. Only a horizontal line is such a line which never has an x-intercept except for the x-axis itself. A line that is parallel to x-axis does never have the x-intercept. So basically, such a line will be of the form y equals some constant, let's say k. So now, as such lines are drawn, you will see that you can have different intersections of such a line with this given parabola. Reason being, if this line lies here or here, it will not have an intersection, it will have zero intersections. If this line is y equals to itself, which is passing through this vertex of the parabola, then it will have exactly one intersection. On the other hand, if it is of this form, in other words, when k is greater than 2 in y equals k, then it will have 2 points of intersection. So I have different possibilities, so I don't have a definite number to how many intersections, hence not sufficient. From the second information, we have the point q2, 1 lies on line L1. Now, we know that there are n number of lines that can pass through this point. So just to interpret it more accurately, this is my parabola. This is the point 2, 1 somewhere around here. Now the line can be from this point, the line can be like this, not having an intersection. It can be a tangent to the parabola having exactly one intersection, or it can intersect here and somewhere above and have two intersections. Again, I have multiple possibilities, not sufficient. Let's combine the two statements and see if we have any possibility. Now, from the first statement, I have that the line is parallel to the x-axis. From the second statement, I do know that it passes through this point. Now 2, 1 is basically having a y value of 1. So my line will become y equals 1 itself, and it will not have an intersection with this curve. So I will have a definite value that I have 0 intersections, and hence now this is sufficient. So my answer is C, because on combining I was able to find that there are indeed no intersections. The line is itself defined. It is a fixed line y equals 1 which does not have an intersection with this parabola. So that was the problem. Thanks for watching and do subscribe to our channel.